Hi guys, I hope you are all doing well. So today we'll see a question which is on the topic of differentiation. So let's understand the question first. It says x is sec p minus cos p, and the next part of the function is y, which is sec raised to np minus cos raised to n, right? So now it is asking me, there are four options given to us. We need to find which of the following option matches with the solution which we get for this. So basically, if you see in all the four options, the options are given with dy by dx. So first of all, let's find the derivative of this parametric functions which are given to us. Now we say parametric because y and x, if you see, both are given in terms of a function of variable which is p. So first of all, if you want to find dy by dx in the case of parametric functions, how do you find that as? I can write dy by dx as dy by dp upon dx by dp. So I can find the separate derivatives for y as well as x with respect to p, right? So first of all, let's do that. We'll find dy by dx and then we'll see which option matches with the four options given to us in the question. So first of all, if I find dy by dx here, so y is given to me sec p raised to n minus cos p raised to n. So if I find dy by dp, differentiating it with respect to p, now you know if there is x raised to n, the derivative of that becomes n into x raised to n minus 1. So here also the derivative will become n into sec raised to n minus 1p into, I am taking a derivative of sec p because it is not x, it is sec p, right? So I will have to again take the derivative of sec p further. Cos raised to np I can write as n cos raised to n minus 1p. Again, further derivative of cos. So I should write dp. Yeah. So now it gives me n. This becomes sec raised to np upon sec p. I can write n minus 1 as sec raised to np upon sec p. That gives you n upon 1. And this derivative of sec p, if you know, it is sec p tan, because derivative of sec theta is sec theta tan theta. So I can cancel this sec with this sec minus n. Again, I can write cos raised to np upon cos p. Derivative of cos p, if you see, it is minus sin p. So now it becomes n sec raised to np tan p minus into minus, that is plus n cos raised to np. And if you understand sin p upon cos p, sin by cos is always a function which is tangent. So tan of. So one more thing I understand from this part is I can take n tan p common. So I'm left with sec raised to np plus cos raised to n. Right? So I get dy by dp. Now let's find dx by dp. X was given to us sec p minus cos p. So if I find the derivative of x with respect to p, sec p becomes sec p tan p, cos p becomes minus sin p, so it is minus of minus sin. So that makes it sec p tan p plus sin. Now again, as we saw in the previous, I was able to find tan p common. So let's try to find out if I can have a tan common here as well. So if I want to take a tan common, I should have tan in both of them, right? So what I need to do is, if I want to adjust a tan p in second term, I need a division of cos p. So what I will do is I'll make an adjustment here. I'll divide by cos. So I'll have to multiply by cos. So that gives me, when I do that adjustment, sine upon cos is again tan. So tan p multiplied with cos. So again, I can take out tan p common. I am left with sec p plus cos p. So now if I want to find dy by dx, I can write it in the parametric form as dy by dp and dx by dp. So dy by dp, that is n tan p and sec raised to np plus cos raised to np. So n tan p sec raised to np plus cos raised to np upon tan p. This is sec p plus cos p. So here if you see, I can directly cancel tan p from both sides. So dy by dx in this case becomes n sec raised to np plus cos raised to np upon sec p plus cos p. Now let's understand, if you see all the four options which are given to you, leaving fourth option which is none of this, if you see first three options ABC, everywhere it talks about the square of the derivative, right? So if I just find the square of that, dy by dx, so dy by dx square, if I take, what I get here is n this square upon this square, right? So n also becomes a square, so n square, it becomes sec raised to n p plus cos raised to n p whole square upon sec p plus cos p the whole square. Now, if you see, I need to find this entire right hand side in terms of x and y as the questions are given, right? As the options are given to us. It says x is sec p minus cos p and y is sec raised to np minus cos raised to n. So basically, if you understand here, it tells me that I need to find the answers in terms of this. So if you see, it is a plus b format, both of them in numerator as well as denominator. Let's make it a minus b format. So you know how to make it a minus b format. So if I want a minus b the whole square, I can write it as a plus b the whole square minus 4ab, right? So if I have a plus b the whole square in this question as it is given, I can write it as a minus b the whole square plus 4ab. So if I write it as a minus b the whole square, so the numerator of the first part becomes, I can write it as a minus b whole square plus 4a into b upon a plus b the whole square in the denominator. I can write it as a minus b the whole square plus 4a into b. So now here also, if you see, I can write sec theta is nothing but what? Inverse of cos theta. So I can write this sec raised to np as 1 upon cos raised to np. Let's do that. So I'm left with n square sec raised to np minus cos raised to np the whole square plus 4 sec raised to np I can write as 1 upon cos raised to np into cos raised to. So this becomes 1 because gets cancelled. I'll close the bracket. Denominator also has sec p minus cos p the whole square plus 4. Again sec p I can write as 1 upon cos p. This also gets cancelled. Again you're left with plus. So now if you understand, what you get here is, it is n square sec raised to np minus cos raised to np the whole square, that was y, so it becomes y square plus 4 upon denominator, if you see, it is sec p minus cos p the whole square. So sec p minus cos p the whole square is nothing but x square, so x square plus 4. So further it tells us dy by dx the whole square is n square y plus 4 multiplied with that and x square plus 4 divided by that. So I get x square plus 4 dy by dx the whole square is n square y square. So this is the option which matches with the question asked, and the question as the option which matches in this is A. So answer for this question becomes A because A is the only option which matches with the options given to us in the question. I hope you have understood how to find the derivative of parametric equations. To build up the summary, we'll talk about this. So whenever you have x as a function of something, let's say theta, y is again a function of theta, let's say. If you want to find dy by dx, how do you find that as? You find dy by d theta means you are finding the derivative of y with respect to theta. Also, you are finding the derivative of x with respect to theta. And then you divide both of them to get the derivative of y with respect to function x. I hope you are very clear with this now. I'll meet you again tomorrow with the next question. Till then, you can see my previous videos for all the previous questions that you can revise, and you can like, share, and subscribe if you're finding this really helpful. Thank you.